Okay, so I just listed down the questions you got wrong. 11, 13, 18, and 19. Okay, can. Hey, there was a previous worksheet, right? But maybe I'll get to that later. I'll deal with these 1, 2, 3, 4 questions first. Okay. Okay, let's begin. So for 11A, the key idea here is that it's a standard cone question. So there will always be two similar triangles. Over here, volume, right? Okay, maybe I should show the question first. Let me show the question first to recap. Was it this file? Oh, this one. Yes. Yeah, here's the question, right? So whenever you have a cone, there's always two right-angled triangles that are similar over here. Can you see the two similar triangles?
Yeah.
Yes, huh? Okay, good. So you should try and copy the diagram. Copy the diagram and draw your own triangle. So let me just go through how to do this. Don't have enough space. I need to add a page. We interrupt the flow. Question 13. Okay, can. I'll just add a page. Okay, so let's take a look at the question. We have a cone where the radius of the entire cone is 16, but there is some water inside that's in the cone shape. The radius is r. Then for that entire cone, the height is 24 cm, while for the conical shaped water, its height is h cm. Okay, so from there you can make a copy of the diagram. Maybe I'll just use black color. And there's a smaller cone. So from here, you can see a big triangle, right angled, and a smaller one, right angled. These two are similar. So it's easier if you just redraw it like this. R here, H here, label like this. And then what was the lengths? Let me take a look first. 24 and 16. Okay, so 24 here, 16 there. So what equation can you form straight away? R over H equals 16 over 24, correct?
Yeah.
Yes? Okay, good. Then from there, let's just leave it first. I don't know whether I want to make R the subject or H the subject. So let's look at the question. The question asks for what? It asks for show that V equals to 4 pi H cubed over 27. So the only variable here is H. You don't want R, which means that you would want to replace every place that you see a letter R with something in terms of H. So it will make sense for you to make R as the subject, right? 16 over 24 times H. Of course, 16 over 24 can divide by 8 on both sides, both the top and bottom. So you get 2 over 3. Oops. Let me bring it back. 2 over 3H. Is that okay?
Yeah.
Okay. So what is the volume of the cone? V equals to 1/3 pi R square H. Which letter do you want to keep?
We want to keep R in terms of H.
Yeah, you
so
want
to keep H.
Keep the H. So which one has to go? The R has to go.
R.
Yeah, so over here you can say sub. Maybe I'll do this instead. I'll just put down an equal sign, copy down everything else except for the R, I replace it with 2/3 H times H. Okay. Then at the side, just remind the examiner who's marking your paper. What do you do? Oh, tell them you substitute R with 2/3 H. Maybe, yeah, this is good enough, I think. Okay, then from there you can simplify it. 1/3 pi times 2/3 H bracket square means 2/3 square H square, right? And times H. H square times H is H cubed. Then the rest is 1/3 times 2/3 square. So 2 square is 4, 3 square is 9. 1/3 pi, let's just copy it down. So 1 times 4 is 4. 3 times 9 is 27. The pi is outside, right? Because it's essentially a pi over 1. So you can just put it at the side, the right side. Don't forget the H cube. Then you're done. Volume in terms of H. Is that okay?
Yeah.
Can okay, good. This is question 11, part A. Let me just label. Okay, then the part B was fine. Your working was fine. So let's move on. Okay, any questions?
Nope.
No one? Okay, next. Question 13. Let's take a look at question 13. Okay, let me see the working first. Oh, blank. Here they said cylindrical column. Do you know what's a cylinder?
Like a circle, but with like length.
Yes, correct. Yes, exactly. So whenever they tell you in English cylindrical column, you must draw the picture. Okay, they never draw the picture, you must draw it on your own. Okay, let me just add a new page. Let's take a look at the question. I'll just copy it over. Okay, so what they say, the radius of a cylindrical column of liquid is decreasing at a rate of 0.02 meter per second. So since they said cylindrical, I'll just draw a cylinder first. Okay, can? It's decreasing, so water is leaking out at a rate of what? 0.02 meters per second. So that's really just the height. Maybe I'll use h for the height. Okay, so dh by dt will be 0.02. Correct or wrong?
Minus 0.02.
Okay, and also
decreasing.
Because it's decreasing. And also I made another mistake, sorry. Radius, they're saying radius. Let me read carefully. The radius of a cylindrical column of liquid is decreasing. So it should be R. Sorry, dr. And maybe I should move my label at the side. It's referring to let me make the circle the same shape. It's referring to this column of water. Then there is a certain radius here. Cylindrical column is decreasing at a rate of the height is increasing. How can it decrease and increase at the same rate? Not too sure. Not too sure. How can the radius be decreasing if it's a cylinder? Okay, let's just label the out. Hello? Yes, I am still here. I am thinking. The radius is decreasing. It's negative 0.02. Okay. If we just Mic test, can you hear me?
Yeah, now I can hear you. I don't know what happened, but then you just started to like
Please. Oh, okay. Okay, sorry. I didn't see the message just now. Wasn't on the screen. Is it okay now?
Yeah, now I can hear you. Just now it's just like hang on like one word you were saying.
Oh, okay. Not sure what's going on. But I'm a bit confused by the diagram. How can the radius of a cylinder be decreasing? Shouldn't the radius always be the same length?
I don't know.
Okay, ignoring that fact, idea, it's probably maybe it's a cone. Maybe it's a very funny shape, where it's made up of multiple cylinders. Like stacks of cylinders. Okay, but that is getting a bit too complicated. Never mind. Don't draw the diagram. Let's just write down the volume first. Volume of a cylinder, base area pi r square multiplied by the height, right? What else is given? They tell us that the rate the radius of a cylindrical column of liquid is decreasing at a rate of 0.02 meter per second. So dr by dt, it has to be what? Negative 0.02. Fair enough. Next, while the height is increasing at the rate of 0.01 meter per second. So in that case, it will be referring to d what by d what?
dh over dt equals
Very good.
0.01.
Do you need a minus sign?
No minus sign increasing.
Yeah, correct, because it's increasing. Okay, good. So now we have dr by dt, dh by dt. Then now we need to find the rate of change of the volume. So
Yeah.
all this is given. Then what we want to find? Let's just write this down.
WDF dv over dt when r equals to h. I mean r equals 0.6 and then h equals to 2.
And h equals to 2. Okay, so from here is a rate of change question where the moment you have dv by dt, you split it up, right? Top, bottom. The top one goes to the top left, bottom one goes to the bottom right. Then you must introduce something that can cancel each other off, right? What would you want to pick? D something.
D can do dv over dr and then dr by dt. But then how do you add yeah, how do you?
Okay. So here I think what they need you to do is to come up with a special trick. Let me see. Okay. dr by dt, we can use this first one, right? Agree so far? Negative 0.02, we can sub in, right?
Yeah.
Then in this case, that would mean that the dr by dt is good. But the dv by dr is a problem, right? Because our formula here is in terms of r and in terms of h, right? So that must mean we need to make use of the remaining piece of information that wasn't used, which is dh by dt, right? This part here. But it's not, how do you link dv by dr to dh by dt? Let's see. I'm a bit confused myself. Let me think. This is supposed to be dv by dr. H in terms of r. Right. Okay. Can we need dv? We need to find dv by dr, which means that we need our volume to be in terms of what? Which letter? R or H?
R
or H? Which one?
It needs to be in terms of R.
In terms of R. So which one do we need to get rid of?
H, but how?
H, to replace. So we have to be a bit clever. Okay, I'll call this equation 1, I'll call this equation 2. Let's take a look. What happens if I take 2 over 1, essentially? dH by dt at the top, dr by dt
over
at the bottom.
dt times both by dt, you get dh over dr.
So 0.01 over negative 0.0.
Oh, really?
And you get dH by dr equals 0.01. Right, let's just simplify this straight away. Yes, you can. Look.
Okay.
0.01 over negative 0.02. This becomes negative half. Okay, that's fine. Then what? Now we want h in terms of r. So sorry, this one actually requires integration. How do you go? What do you
Negative half r, negative or
start with h,
negative,
right? A function of r.
Negative r over 2.
Negative r over 2. Oh, right, correct, yes. Yes, You just have to start with negative half r. You differentiate and you get negative half. Sorry, differentiate negative half r. Differentiate, you get negative half. Which is r over 2. But what if you have an extra plus 1? Does that also work? If you differentiate?
Yeah.
What if it's a
Then
plus
how?
2?
Yeah,
What if
it's
a plus 3?
but then how did
What if it's a
then
minus
how you
1, minus 2, minus 3? So what you should realize is that there are multiple different possible things you can add on, but they are always a constant, right? So that means it's really just plus c, a constant. I haven't introduced integration. That's why you don't know this. I'm so sorry. I didn't. I should go and cut out those questions that have integration. This arbitrary constant will always appear when you are doing integration, specifically indefinite integration. Okay, in general, make sense? If you plus 2, you differentiate, it becomes a 0. If it's a plus negative 5, you differentiate the constant, it becomes a 0. So when you integrate, you have to capture all the possibilities with a generic letter C. Okay. Usually we use the letter C, can be other letters. Is that okay?
Yeah.
Can yeah, sorry, there was an integration step over here. So now let's take a look at this equation. H of r equals to negative half times r plus c. From here, we can actually solve for c first before we substitute it back into the equation here, right? So let's see. At the beginning, let me read the question. Were there any clues given to us? Radius 0.6, the height is 2. Okay, they told us something. They told us that when the radius is 0.6, the height is 2 meters. So this is paired together at the same time. Okay, is that acceptable? Ken? That was a given condition, right? So that means that we can actually substitute. This h is the same as h of r.
Sub 2 equals to minus half times 0.6. Then you find c.
So you can sub h of r with 2 and r with 0.6. Yes. And from there, you can solve for c. Maybe I don't need to say h of r. It's a bit confusing. I'll just call it h. Is that okay? It's a bit like how you have like a equals to pi r squared. A will now be a function of r. But you change the value of r over here, the radius of a circle. Pi r squared is the area of a circle, and r being the radius. So a is actually the same as a of r, right? Using function notation, like f of x equals x squared, that kind of notation. It's just that here, usually we don't put the bracket r. We just drop the bracket and we just write our a. But it's implied that it's a function of r. Is that okay?
Yeah.
Usually dropped for simplicity. Okay, so after we sub in h equal to 2, r equals 0.6, so let's see what we get. Negative half times 0.6, u plus c. 0.6 over 2 is 0.3, so negative 0.3 plus c. So therefore c equals to 2 plus 0.3, 2.3. This implies h equals negative half r plus 2.3. Let's call this equation 3. Okay? Okay. Then from there, okay, wow, I didn't label it. Let's just call this star. Star. Now we will sub 3 into star. Let me copy down equation star first. Why are we substituting 3 into star again? Remember the ultimate goal?
To change the v in terms of r. So you want to get rid of the h.
Very good. Yes, exactly. Okay, so therefore v equals to pi r squared multiplied by h, but in this case it's negative half r plus 2.3. Then you have to multiply in, I guess. You can keep it as a product and then differentiate with respect to r using product rule, but I don't like product rule. I would like to go for the simplest way possible, which is multiply the r squared inside. Then I proceed to differentiate. Okay, so I end up with negative half r cubed plus 2.3 r squared. Then from there, dv by d, what's the letter?
dv by dt.
Here got T, man.
Wait, no, dv by dr.
dr, you follow the letter. R
Yeah.
here, R here, R here. Okay. Function of R. So so the independent variable, the bottom letter must be the same. Okay, so just differentiate pi. What I'm doing is I am factoring out the pi. So pi multiplied by d by dh of negative half r cubed plus blah 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 blah. Usually I will skip this step and just go straight to the next line, which is pi times differentiate negative half r cubed. What do you get?
Negative 3 over 2 r squared plus
Yes.
4.6 r.
Okay, very good. So this is dv by dr. Can you continue the rest? Can, right?
Yeah, because you
And
have dr over dt. After that, you just need to sub in r equals
I'm
to
running out of letters. Let me
0.6.
asterisk. Okay, you can continue the rest.
Okay.
Sub dv by dr into asterisk. And you can fill in the rest. The initial conditions as well. Which were radius is 0.6, height is 2 points. Height equals to 2. R equals 0.6, h equals to 2. Just remember to sub in those two values as well. Okay, Ken. Interesting question. Next, question 18. What's question 18? Let me see the question first. Oh, these are out of syllables. Do you want me to explain? Those that are out of syllables.
Why even be able to understand?
You need to learn integration. Then there was a topic on separation of variables. Okay, maybe not. Maybe not. We'll go through it on a different lesson after you learn integration. And then we'll come back to it if we have time. Okay, let's look at this question 18 instead. Okay, this one should be doable. Just need to think a bit. Our security spotlight, okay, is situated at 10 meters from a straight fence. The spotlight rotates at a constant speed and makes one full revolution every 12 seconds. The situation at time t seconds is modeled in the diagram below, where L is the position of the spotlight, so spotlight over here. G is the point on the fence nearest to the spotlight. The fence is over here, then G is the point that is nearest to it, so it must be a perpendicular distance, perpendicular height, sort of. P is the point, is the position where the light hits the fence. Okay, so there's a beam of light. It's currently at a certain angle theta, and it's pointing at point P, this part of the fence. Okay, theta is the angle between LG and LP. Yes, X is the distance in meters from G to P. Okay, and this is 10 meters. Right, because the spotlight is situated 10 meters from a straight fence. So 10 meters here. Okay. Can understand the story so far? Yes, Okay, good. Here they gave you one important line, which is one full revolution every 12 seconds. One full revolution is how many degrees?
$360.
360 degrees. But here, because we are going to be doing differentiation, I forgot to, did I not emphasize this? When you're differentiating for sine and cosine, right? Like I told you that differentiate sine of theta gives you cosine theta, right? But I think I didn't mention this. My mistake. Theta must be in radians. The reason is you need to learn, before I can tell you the reason, you need to learn about the limit definition of a derivative. And in the proof for why the derivative of a sine is a cosine, we make use of the fact that theta is in radians. If it was not in radians, it was in degrees, we will need to treat theta as a function of degrees. So theta will be something like, what is it? 180 degrees over pi of, let's say I use a different letter, alpha. Right, okay, maybe I shouldn't write this down as theta. I should write it down as, if I wanted to use alpha degrees, it will be the same as 180 degrees over pi radians times theta radians, right? If theta is in radians. But now I want to use alpha degrees. So now alpha is a function of theta with an extra coefficient 180 over pi, right? So that means that if you try to differentiate d alpha with sine of alpha, where alpha is in degrees, we need to use chain rule. Differentiate sine, you get cosine. The inside remains the same. But now alpha is a function of theta. So you actually need to, oh, sorry. This should be theta. In radians. This guy is degrees. Then you multiply by the derivative of alpha with respect to theta, which in this case will be 180 over pi. Okay. Basically, remember this formula, the theta must be in radians, not degrees.
Okay.
Must be radians. I forgot to mention that. Is it? Did I mention before?
I don't know. Maybe.
Yeah. Please help to remember this. Likewise for cosine, likewise for tangent. Differentiate cosine, you get negative sine. Differentiate tangent, you get secant square. But the degree, the theta must be in radians. If it was in degrees, you will need an extra 180 over pi factor because of chain rule.
Okay. So
Okay. Yeah,
you
that's just
differentiate this, then you differentiate the inside of this. Then change. Wait, you change the degree or what thing? Like
if this is in a situation where if you start off with sine of alpha instead of theta, where alpha is in degrees, or any other letter, I use alpha because I like alpha. Then with respect to this function at the bottom must still be theta. It must, which is in radians. It must be radians. Cannot be in degrees. Okay, maybe it can. If it is still in degrees, not sure.
wait,
I don't think you.
But okay.
Okay.
Wait, how do you wait, how do you go from here to here again?
Okay, you treat this as a composite function, sine of alpha.
Yeah.
There's an outer function f of
fx.
Let's say theta, that is sine of theta. Then there's a g of theta, that is alpha, or rather, sorry, 180 over pi theta, which is alpha. Okay, so sine of alpha is actually f of g of theta. Sine of alpha is like sine of 180. Oh, nope. Let me check the conversion rate. Did I do it correctly? Yeah, 180 over pi theta. Okay. Maybe it's not clear. Maybe it's nicer if I write down both. This guy equals to this guy. Then differentiate sine, you get cosine. The alpha is really just 180 over pi. 180 over pi times theta. Wow, it's getting a bit confusing. I think I better keep it to alpha. Instead of writing 180 over pi theta, this is just alpha. Differentiate sine of alpha, you get cosine of alpha. Then alpha is a function of theta. So you d alpha over d theta. But alpha is what? 180 over pi, some coefficient, some number of theta. So you just get 180 over pi. Does it make sense?
I think I need to see actually do it.
Okay, let's try an example. Let's say
Yeah,
that
yeah.
you d by d theta of cosine alpha. What would this be equal to? Alpha is in degrees.
Alpha is in degrees, so you
Theta is right.
d over d theta cosine alpha.
Okay. Actually, these two are exactly the same.
Yeah.
So
Okay.
there's no point. Sorry, let me remove this.
Negative sine alpha
Negative sine alpha. Good.
times times d alpha d. So you differentiate d alpha over d theta.
Yes, exactly. So negative sine alpha remains.
Alpha times 180 divided by pi.
Yes. If you want, you can do one extra line. Replace the alpha with 180 over pi theta times 180 over pi, so that it's a function in terms of theta. Okay. Yeah, but usually you won't get to see this problem. The theta will always be in radians once you are in differentiation, integration. Well, once the question starts talking about differentiation and integration of sine, cosine, tangent, they will usually always give you theta in radians. Only when they are really trying to trick you, then they will give you degrees. Then you need to remember chain rule, extra factor of 180 over pi. Can? Try one more. I just go through this one because it's not very relevant to this thing. If it's tangent alpha, then it will just be differentiate tangent. You get
Secant
square.
square
Then what's inside? Still alpha. Then times
differentiate alpha d alpha over d theta equals to secant square alpha times 180 over pi equals to secant square 180 divided by pi times theta
times 180.
180.
Yeah. So please take note that for trigo you cannot simply factor out the 180 over pi. You cannot just take it out. Right? Yes, I'm sure you know that. Like cosine 2 theta, is it 2 times cosine theta? No, right? Double angle. Got all the formulas, right? Yeah, just remember, you got a factor here, you don't go and factor out. Just be careful of that. Okay, that is off tangent already. Let's come back to the actual.
Wait, can you say the last sentence again?
Off tangent.
Don't factor out the
yes.
Yes,
this is not equal to 180 over pi times secant square of theta. Please do not factor out.
Yeah. Okay. Yep.
Wrong. Cannot.
Yeah.
Okay, can. Yeah, back to the question. Okay, so we already have the question. At the end of the day, it's just a triangle. So you just have to deal with a triangle. Let's look at A part 1. D theta over dt equals pi over 6 radians. Do you want to show that? How? So let's see. Theta is in radians, right? Theta is in radians. Oh, give me a second. Let me just copy this page first. To the correct place. I'll paste it here. Yeah. Okay, without the other stuff. Okay, maybe I will copy that. Sorry, give me a second to edit this. And I'm gonna clear this. Oh, nope. Go back and good. Okay, can. So how do we show that d theta by dt is equal to pi over 6? What you need to do is to make use of this line over here. What was I saying? I was asking you one revolution, how many
360
degrees? 360.
360 degree go on.
But we are working with radians, so 2 pi radians. Is that okay?
Okay, 2 pi per 12 seconds.
So that means that d
Don't tell
theta.
me it's 2 pi divided by 12.
Yes, that's all. That's it.
Huh? Are you serious?
Yes, then you get pi over 6. Because they told you that it's rotating at a constant speed, right? That means that the d theta by dt will also be a constant. In this case, pi over 6. Just 360 degrees, 2 pi radians divided by 12 seconds. Okay, so that will be radians per second. Don't need the units. I think it's clear enough. It's that, I mean, they already told you. Is that okay?
Okay.
Yeah. You just have to quote this. Since one revolution is 2 pi radians, 1 rev, 2 pi radians, and 12 seconds for 1 rev. Then the rate is just a simple rate question. Total divided by time. You get the speed. Distance divided by time, give you the speed. Okay, but next one, dx by dt equals to 5 pi over 3 secant square theta. This one is a bit tougher. But not too bad. Let me just show you. Dx by dt. What is x? X is one side of a right angled triangle, right? So is there an equation we can form? Right angled triangle. If you start off by thinking Pythagoras theorem, yes, maybe, but that will require 3 lengths, right? We have 10, we have x, but what's this? Do we have the hypotenuse?
Can find it. Goes to 10 square root 100 plus x square.
Right?
Yeah.
Then how? Then how do you link it to dx by dt?
How do you how do you link it?
Can you? That's not what I'm thinking of, lah.
Then,
Is there a way? I don't know.
Tangent tangent theta equals to opposite x over 10.
Opposite over adjacent. So
X
x
over
over
10.
10.
Then
Okay.
then okay, I just guess this cause is say one secant square theta.
Very
then
good. Yeah.
Need to, but then how do you?
Then how do you continue? Let me leave a bit more gap here. How about if we just differentiate both sides of the equation?
Okay. Get
But what is your
secant
choice of happy face?
theta. Wait. What is my
Carefully at
choice
this
of?
question. Okay, what you want? Dx by d?
d1 dx by dt.
dt.
How do you?
But cannot. Oh, sorry, you haven't learned implicit differentiation technically. Okay. Hold on. Then maybe we choose theta first. We choose theta first. Okay, we choose theta first. Let's choose theta. Then differentiate tangent, you get what again? Secant square, right? Of theta, yes?
Yeah.
Okay, so far, the left side. Okay, when this one, how? One is theta, one is x. How?
Yeah. How?
Maybe at the side, we can do the following substitution.
X equals to 10 times tangent
A equals x over 10. Now what we are really asking is how to find dA by d theta. Right? How to find dA by d theta. But you can always do the chain rule trick. So, was that what you were thinking of?
Nope.
No? But now you know. What is a good letter to pick?
dA over dx.
X, exactly. Because A is in terms of x. Right? So what's dA by dx? 1 over 10. Right, this is 1/10 over x.
D theta.
Dx over d theta. Dx over d theta. Where have I seen? So okay, what do I need? I need essentially x that's in terms of X in terms of what letter? Or what variable? If I want to find dx by dt though. Hold on, I'm pointing at it already. X in terms of
Theta.
theta, yes. Hey, hold on, let me think. Am I going on the right track? Or am I talking nonsense? Let me double check. Try to be sure it's like X. Hold on. I'm making this too complicated already. Sorry. This is just a rate of change question. What am I doing? Sorry. Let me start again. Okay. This part, box it up. I don't need it. Start with this guy. Okay. Tangent theta equal x over 10. That's the clever observation you need to make in a right angled triangle. Next clever observation we want to make is dx by dt. We can split it. This is part 2. So we can always make use of part 1. What do we know from part 1? This guy. Theta on top, t below. Here we got t below. So what should be on top?
D theta.
D theta, right? Then of course at the bottom must be the same to cancel
Theta.
off. Okay. Right, rate of change. So this part, d theta by dt, we know is pi over 6, okay?
Pi over 6.
Then now we need to figure out dx by d theta. That's the question. That's the problem. So if you look carefully at this guy, what do you notice?
X equals to 10 theta. X equals to 10 theta. Differentiate x.
With respect to theta.
With respect to theta, become
factor
okay,
10 times something. Factor out first. Yes.
Tangent theta, which just becomes 10 secant square theta. 10 secant square theta times. Wait, something not right.
Why?
10 divided. Oh, wait, no, yeah, it's correct. Yeah, it's correct. It's correct. Yeah,
then you just get the final answer, right? Don't scare me. Okay, 5 pi over 3 secant square theta. Okay, that's it.
What the hell?
Sorry, I was confusing you. Don't need so much. Okay, so let me just write down whatever you've written. So tangent theta equals x over 10, so we can make x the subject. X equals 10 tangent theta. So of course dx by d theta, you can factor out the 10, then d by d theta of tangent theta. But differentiate tangent, you get secant square theta. Okay, so 10 secant square theta, I don't need the times anymore. Then you just substitute in. Okay, good. Interesting question. So now that we have these two, we still need to solve for part B. You already did it, but very long-winded. Correct. It's correct. But very long. Where was the working? Let me find the working. Where was it? All the sines and cosines. This one, yes. First attempt wrong. Then followed by this one. Can I just show you an alternative method? Oh, sorry. Before that, the one careless mistake you made here. Here cosine power 4 is cos square of square. Right? I mean cos square squared. Then 2 sine square cos square is just 2 sine square cos square. Plus.
Yeah.
Then sine power 4 is sine square square. So this becomes a plus b bracket square, right? Using this formula. So what you did was you wrote it as a square plus b square, which is very different. It is not the same as a plus b bracket.
Okay.
Right? Understand? Yeah, so it's not the same. However, luckily for you, the numerator is still a 1. Okay? numerator is still 1. At the end of the day, what you should have done is to rewrite it as this format, a square plus 2ab plus b square, then factorize it as a plus b bracket square. So cos square plus sine square, then bracket around it, then square outside. But what's inside the bracket? Cos square plus sine square. So what's cos square plus sine square?
1
Is 1. So that means you get 1 bracket
square, yeah.
which will give you 1. So at 1 over cosine square, secant square. So your working is still fine. Let me show you a shorter way. That doesn't involve so many steps.
Wait, can I ask you something? Is
Yes.
it not possible, right? To like, cause they give what's the thing that they give 10 1 plus tangent square theta equals to secant square theta, is it?
Yes.
Is it not possible to like change the thing to secant square minus tangent square theta equals to 1?
Can, perfectly fine. You can do
Then
that.
how do I present to like
How to present it?
for
Okay,
like if I want to change it to that.
Okay, let me show you. Use the if and only if symbol. They're asking you to WTP. You want to prove. This is your objective. 1 plus tangent square theta equals secant square theta. You can just say this is equivalent to proving 1 equals to secant square theta minus tangent square theta. Then from there, you write this down. Then you have LHS equals to 1. RHS equals to secant square theta minus tangent square theta. You know why they are equivalent, right? Bring over, just minus. Plus become minus.
Yeah.
Right? Then from there, you can carry on with whatever tricks you want. I don't know how to do it for this other method. Can I just show you a shorter, simpler way?
Yeah.
This is just showing you the presentation. The alternative method is simply to realize that we know the following. Sine square theta plus cosine square theta equals to 1. Right? So that must mean that dividing by, let me see, cosine square theta throughout. What does divide throughout mean? It means 1 over cosine square on the left, 1 over cosine square on the right, multiplied by, maybe it's nicer if I write it on the right side. Right, divide is the same as multiplying by 1 over the whole thing. Sine square theta plus cosine square theta equals to 1. You agree with this one, right? Sine square plus cosine square equal 1.
Yeah.
You can also, if you really want to, you can show it. This is, let's call it ABC. Sine square theta will be opposite over hypotenuse bracket square, so b square over c square. Cosine square theta equals adjacent over hypotenuse bracket square, so a square over c square. And finally, sine square plus cos square, you just add them together. Sorry for the bad handwriting. Sine square theta plus cosine square theta equals to b square over c square plus a square over c square. Denominator is the same. We write as a single fraction, b square plus a square. But wait a minute, right angled triangle here. So what's the theorem you know? C square equals?
Pythagoras theorem, a square plus b square.
A square plus b square. So you realize b square plus a square is here. A square plus c square, same thing. So it's really just c square. So numerator becomes c square. Denominator is still c square. Cancel off, you're left with 1. Can?
Yeah.
Right? Okay, good. Then here, divide, or you multiply in. So what you essentially get is sine square over cosine square plus cos square over cosine square, cos square over cos square, cosine square, cos square, same thing. And 1 times 1 over cos square. Now is when the magic happens. Why did I even want to divide by cosine square in the first place? Is because other than the fact that I have the answer key, it's because I saw this guy, tangent square. Tangent, how do you link it to sine and cosine? Do you remember the formula? Tangent equals to what over what?
Sine theta over cosine theta.
If I change this to alpha, then it's alpha and alpha.
Alpha.
So just adapt accordingly. Theta, theta, then theta. Okay, so it's sine over cosine. But we actually have sine tangent square, so it's sine square over cosine square. What do you notice over here?
Tangent square theta.
Tangent square. Maybe I zoom out so you can see the. Okay, never mind. I copy the WT field, what I want to prove on the side. And then you should be able to tell where I'm going already. So sine square over cosine square is actually tangent square theta. Cos square over cos square, cancel off. You're left with a 1. Equals to 1 over cosine square is secant square. Right? 1 over cosine is secant. Co no co. Remember? Mic test, am I still connected?
Yeah.
Like this. And the last one is cotangent theta equals 1 over tangent. Co, no co. Okay. Here no co, here have co. Here have co, here no co. Here have co, here no co. Yes co, no co. Yes co, no co. Yes co, no co. Clear?
Yeah.
Okay, very good. Yeah, so therefore we get this out. Tangent square plus 1, of course, is the same as 1 plus tangent square. If you really want to be strict about it, you can say addition is commutative. You can swap the order. Left plus right is the same as right plus left. And then we are done. Commutativity. You can go and Google this if you want to study abstract algebra. Commutativity. Commutativity, associativity, there exists a zero vector. If the zero vector exists, then there exists a negative vector. The axioms for field. Okay, not relevant, never mind. But whatever, we have proven it. Bracket, proven. Okay. Okay, good. That is only for question part B. Moving on, part C. Hence or otherwise find the exact value of dx by dt when p is 5 meters from G.
Yeah, I don't know how to do that.
So let's take a look. So when p is 5 meters from G, what is it really saying? It's saying that x equals to 5. So let's just write this down. Bracket x equal to 5. So what we are trying to do is dx by dt sub in x equal to 5. Here you notice a problem straight away. Sub in x equal to 5.
They give dx over dt
already given.
Yeah.
But it's in terms of theta.
Theta.
Not x. If this was x, then it would be easier. You can just sub in.
Yeah, just sub in. Yeah.
Then how?
But I still cannot get I did tangent. What I do? Then tangent. Wait, what I do?
What do you do?
Like, I try to find theta. Yeah, tangent. Tangent theta equals to 5 over 10 cos x equals 5, right? Then theta equals to tangent inverse half. Tangent inverse half. But then if you sub tangent inverse half into here, right? Then the calculator don't give me an exact value. Even if I don't put in the pi. Like, you know what I mean?
I get what you're saying. Yes. So
yeah,
that's
how
you have to think carefully. You can use special identities involving inverse tangent, inverse sine, inverse cosine, but that is a bit too overpowered. You don't need that. What you need to do is to be clever. What is secant square theta? Okay, what is the problem here we have now? We want to sub in x equal to 5. So if you do a bit of wishful thinking, you would wish that, wow, if only there was an x, not theta. If this was x, it's so easy, just sub in.
Yeah.
So you need to come up with an intermediate. You need to somehow convert this into something in terms of x. Then you can sub in x equal to 5. Then you can go back to secant square theta. So how do you bridge the gap between secant square theta with something in terms of x? You look at the diagram. What is secant square theta?
Secant square theta is 1 over cosine square theta.
So it's really just 1 over cosine theta, then you square it. What is cosine theta? Look at the diagram.
Cosine
half.
theta adjacent, so 10 over hypotenuse.
Which is
This,
what you told me just now?
yeah.
This guy.
Square root
Ah.
100 plus
Everything in terms of x already. Then you just sub it back in. So 1 over cosine, flip it upside down. 10
You
square
really
plus
get exact value.
Huh? Sorry?
You really get exact value.
Yeah. Yes, of course. Just the square, as long as the square root is there, then you get exact value. So let's just work it out. So therefore, secant square will be just this guy square.
5
No
over
space.
4. It's 5 over 4.
Is it 5 over 4? I'm not sure.
Yeah, you get the secant square theta is 5 over 4. What the hell? Then you legit get exact value.
So yes, correct. 10 square, I'll just evaluate
why?
as 100.
Then
So
why?
secant,
Huh? Oh,
so 100 plus x square over 100. Okay, let's just record it down first. So therefore, this part here becomes 5 pi over 3 multiplied by, what's that? 100 plus x square over 100. Very nice. Then you substitute x equal to 5 here. But please remember there's a pi over here, so it's actually 5/3 pi times whatever is the number here. What was the value you got after subbing in the 5 square? 100 plus 5 square, right? Which is 125 divided by 100. This becomes a 5 over 4. Don't forget the 5 pi over 3 in front now.
yeah.
Okay, this one is clever trickery. Clever trigger. Then as a result, what's this? This is sub x equal to 5. And finally, as a result, you get what? 5 times 5, 25. 3 times 4, 12. So it's actually 25 over 12 pi. Yeah, you don't forget the 5 pi over 3. Is that okay?
But why? Okay, I mean this makes a lot of sense.
Ah.
But then why is it when you do tangent inverse, whatever it is, then tangent inverse half, then you sub into the theta. Yeah, why is it not exact value?
Is it?
Okay.
You didn't use the exact calculator value, is it? Let
I
me.
did. I changed 5 like
Were you using radians?
or maybe.
Must
Wait.
be in radians.
Oh wait, I think I was using degree. Wait, no. I recall changing to radian. Wait, I
Hold
try
on,
again.
I also need to check. I'm not sure of the value. Tangent inverse of half in radians is 0.4636. Okay, let's work it out using your method. Wow, not enough space. How? I'm gonna shrink it down. If we worked it out using tangent inverse of half, then dx by dt would be 5 pi over 3 times secant square, which is 1 over cosine square of theta, which is 5 pi over 3 times 1 over cosine square of tangent inverse of 1/2. Actually, you can just key in this entire thing in the calculator. You don't need to evaluate it. You should be able to get an exact answer.
Okay.
But this part, the 5 over the part that you don't, of course, you don't type the pi in.
Yeah. Wait, I try. Hold on. Cosine tangent inverse 0.5
square.
Oh,
Yeah,
I get
yeah,
exact
25.
value.
25 over 12.
That means I did something wrong. I either didn't change to radian or I don't think I don't know what I did. Yeah.
You never use the exact value.
No, it cannot be because okay, wait, maybe I don't know.
Yeah. I also don't know what is the exact value of tangent inverse of half. No idea. Doesn't matter. Okay, could we find out? Actually, we can possibly find out what is the exact value of tangent inverse half. Cool. Wait, actually, no, not really. Okay, oh no, but if you take cosine of tangent inverse half, it is possible to find out the value. Without with the use of a diagram. Okay. How would you do it? Let me show you how to evaluate this guy without a calculator. Get the exact value. What you need to understand is that cosine square is really just the same as putting a square bracket outside and then squaring this whole thing. Okay. So what we need to find out is this cosine of tangent inverse half. First thing you should do straight away is to draw a right angled triangle. Give this angle here the name tangent inverse of half. Okay, you must remember when you inverse, it becomes an angle. This whole thing becomes an angle. Make sense? Correct or not?
Yeah.
Right.
Yeah.
Tangent theta equals opposite over adjacent. You bring the tangent over tangent inverse of a fraction. That's a theta. So why would you do 1/2? It must be opposite over adjacent.
Over adjacent.
So it must be 1
and 2
and 2 here.
square
And what's the
root.
hypotenuse?
Square root 3.
1
Root
square
3.
plus 2
Root,
square root.
root 5. Root 5.
Root 5. Good. So what is cosine of that funny angle? Just to adjacent over hypotenuse. I have
2 over
adjacent.
root 5.
I have hypotenuse.
2 root 5 over 5.
So what's cosine square of the funny angle?
4 over 5.
Exactly.
What the?
Okay, 4 over 5. Hold on. Wait.
That's the same as the thing we got just now.
Yeah, exactly. Yes. Then 1 over will become 5 over 4. 5 over 4, then 5 over 3 and 5 over 3 factor as well. And finally, yes, 25 over 12. Okay. You need to use a diagram. There are actually, you can go and Google all these special identities involving a trigo function with an inverse of a trigo. They list out all for you, but I don't remember. Nobody ever remembers those. You just draw the right angled triangle. Tangent inverse of half. Tangent inverse is an angle, so you draw it as an angle in a right angled triangle. Half is must be opposite over adjacent since it's linked to tangent. Then opposite must be 1, adjacent must be 2. Right. Then from there, find the hypotenuse length. Take the cosine of the angle adjacent over hypotenuse. Square it 4 over 5. Yeah, that's how you evaluate it. Okay, the trick. You will need to learn this in the future in engineering mathematics if you're doing integration. This kind of tricks. But yeah, this question, AMAX student can handle. Yeah, but the concepts from engineering math is brought in, which is very interesting. Okay. Good. Yep. Okay. Yeah. Okay, move on. What's the next one? 19 part 2. Right. There is an error with the question. Oh no, not yet. Sorry. That was another question. I'll talk about it later. 19 part 2. Okay, 19 part 2, what happened is there was a mistake with your interpretation. Let me just copy the question down so it's easier. 19, what's my 19? Here we go. Your part 1 is very good, but part 2 not so good. Let's read the question. A point moves along the curve in such a way that when x equal to 3, the rate of increase of y with respect to time is thrice the rate of increase of x with respect to time. So you know that there's a 3 times going on already. There's a dy by dt. There's a dx by dt. Then there's a times 3 going on. Is it times 3 here or is it times 3 here? Either or. Right? Which is which? So let me ask you a simpler question. If Alice has 3 times the number of apples as Bob, let's just say that they are fruit sellers or something. Then let Alice have X number of apples, Bob have Y number of apples. Form an equation in X and Y. Is it 3x equal to Y?
Okay,
or X equal to 3?
Yeah. X equals 3y.
X equal to 3y, right?
Yeah.
So here, how come you put a 1/3 for me?
Okay, wait, but assuming that I put a 3, right?
The rest of the working is fine, yes.
Oh, okay.
Yeah, go and do your correction, okay? This one, don't 3 times, please work it out. Which is the 3? I don't like to think of it as 1/3. I just think of it as 3. You just think of the whole number 3, and then you figure out where you should park the 3. Here's how I do it. Just to let you know. When I see 3 times, right, straight away I know Alice has bigger number of apples, right? So that must mean that if sorry, let me see. I think I might have did something wrongly. Let me just do a quick swap. Whoop, whoop, whoop. Y here, X here. Yeah, that's better. Yeah, so the moment I see that something has 3 times, right, that means that person has more. In this case, if Y represents Alice's number of apples 3 times, right, it must be big. Then the other guy must be small. Then if you keep it as 3 times, you only have 2 choices. It's either 3 times small gives you big, or small big times 3 gives you small. One of them makes sense, the other one doesn't. If it was the other way around, does it make sense? Big guy,
Yeah.
you times 3, it becomes bigger, right?
Yeah.
Let me make a correction. Yeah, this is better. Bigger equals to small is impossible, right? But if you take 3 times of a small, you get big. That will make more sense. Okay. Yeah. Okay. You slowly go and work it out, It should be a 3, not 1/3. Okay. Yeah. Moving on. There was another question. This part. This one is the times 3 or 1/3. The other question, what was that? Let me find first. Forgot the question number. It's a question 20. Yeah, interesting question. Sorry, this question actually requires integration. It actually requires integration. You might not be able to do it, but I want to go through with you since we're gonna start the next topic already. Okay, or do you want more practice for differentiating the sine, cosine, tangent, e power x, ln x? Do you want more practice with that? Differentiate ln, differentiate e.
I don't know.
I think it's safer if we go through more in depth.
Okay.
I'll assign you homework for that. And also finish up the rest of the questions. Wait, let me just quickly tell you this. Question 20 here, the cone was very badly drawn. I'm so sorry. It should be like this. The circular base, it should be center aligned, not slanted. You can see it's a bit slanted, right? Yeah, it shouldn't be. Sorry. Wrong diagram. You update the diagram. 4 here, 20 here. This is question 21. You haven't do yet. Okay. Yeah. Just help me to take note. Somewhere. I'll just write it down. Update Q21 diagram. Not supposed to be slanted. Cone is not supposed to be slanted. Yeah. Okay, Ken. Anyways, back to the question 20. Let's take a look. This question is a bit difficult. Okay, so what you have done so far was very, very correct. Okay, so you are given this question, you are asked to find the rate of decrease of the volume of the water when t equal to 2. But sorry, there is a mistake I made with the question. This is not 4t plus minus 1, it should be 4t plus 1. Okay, so sorry about that. Can you help me to record this down? Yeah. Error with question, sorry. Typo. It's supposed to be plus 1. Okay, so it's negative of 4t plus 1. Sorry about that. That is the first thing. Second thing, what did they ask you to find? Find the rate of decrease of the volume of water when t equal to 2. Exactly this, which is correct. What you want to find is dv by dt given that t equals to 2. You're given a formula v in terms of h, so you just differentiate with respect to h first. That is correct as well. And you eventually end up with this h squared plus 4h over 10. Correct. What they want, dv by dt, rate of change trick is to split it up. dv at the top, dt at the bottom, introduce a letter In this case, you use dH. That is also very good. Why? Because dH by dt, we have the value. It is a formula 4t plus 1. All right. 4t plus 1 plus, sorry. And because it's decreasing, you have to put a negative sign. Okay. Then now you have the problem. Here is in terms of h, here is in terms of t. Then how to proceed, right? Because what you want is to substitute with t equals to 2, as what you have written over here. dv by dt, substitute t equals to 2. Substitute t equals to 2. So the problem now is, here you got t, substitute with 2, very easy. Here you got h, I don't know how to substitute, correct? Are we on the same page?
Yeah.
Yes, so you have a problem. You don't know what is the h to sub in. So that's when I have to say, I apologize. I should have assigned this question later. This is a very difficult rate of change question because it also requires integration knowledge. In order to be able to figure out the value of h to sub in, you need integration knowledge. I will introduce it now. So what we have over here is that dH by dt equals to the negative of bracket 4t plus 1. Again, sorry, it should be a plus, not minus. So if you multiply the negative in, you get minus 4t minus 1. Then from there, dH by dt equals to something in terms of t. You can actually do what's known as integration to try to get the h. Okay, because the opposite of differentiation is integration. I'll introduce it officially at a later time, not today, not officially today. H becomes dH by dt is the forward direction. Now integration, you just walk backwards, get h. So if you integrate to go from dH by dt to h, on the right side, you also have to integrate. I skipped one step. What's really going on over here is, if I can just squeeze it in, just to show more working, is that I have dH by dt equals to negative 4t minus 1, and I am integrating with respect to t, I am sort of doing the funnier version of differentiation, right? Previously, it was like d by dt, now change into integral dt on both sides. The dt and dt can cancel away. There is an invisible 1 over here. Integrate 1. Oh, so the dt cancel away, so what you're left with is integral of 1 dh. Integrate 1, you get h. Right? Differentiate h, you get 1. Work backwards, you get h. Okay, I'm skipping a few steps. If you can catch what I'm saying. So far, hopefully.
Yeah.
So h equals to integral of this guy. So that means that if I can just squeeze the working over a bit more to the right, what I end up with is h, dh by dt, integrate become h. Integrate negative 4t minus 1, you get this. Then now you can just work backwards. How can we obtain negative 4t? You can factor out the negative 4 and focus on the t. Differentiate what gives you t. There's only one answer, t squared over 2. Right? You try, differentiate this, you get t. Yes, right? Okay, then times negative 4, you just times negative 4. So it's the same. How about negative 1? Differentiate what gives you negative 1? Must be negative t. Right? You try, differentiate negative t. Get the coefficient just negative 1. Okay, but remember, there's always this thing about the constant plus c. Okay, just accept it for now, plus c. 4 and 2 cancel away. Then you're left with negative 2t squared minus t plus c. Okay, so far? Just accept,
Yeah.
You get this as an answer. So h, you differentiate this, you get back to minus 4t minus. Okay, good. Then what else were we given? We were given that at the beginning, though there's water flowing out, you can assume that the water is fully filled at the beginning, okay, by default. Let me write this down. By default, assume volume of water equals to volume of container, meaning the container is fully filled. then you slowly let the water leak out. What does this mean? It means that at t equals to 0, at the very beginning, the V must be exactly equals to the volume of water. Container. This V over here represents the volume of the water so far, right? So maybe I shouldn't put water here. I'll just remove this water. Okay. At t equals 0, the volume of water must be equal to the volume of the container. Do you agree with this so far?
Sure.
Yes, right? Yeah, fully filled. But what else did they tell you about the volume of the water? It's equals to 10 plus whatever thing in terms of H. And the H refers to the depth of water, the height of the water. If the container is fully filled with water, what would be the height of the water?
Fully filled and then H.
It will be the same as the
20.
height of the
20.
container, which is 20, right? So that means that volume of water here is the same as volume of the container. This is the formula for volume of water with a changing height.
So when t equals 0,
H you can start with 20.
yeah.
Right. 20 equals 0. Huh?
No,
Did you
when
say
t
20 equals 0?
No, when t
Oh,
equals 0, then,
when t equals 0.
then
The volume of
V
container was
equals
just T.
to, when you sub in H equals 20, then you get V when t equals 0.
Exactly. 20 squared. Okay, I already wrote down the working at the bottom, but I just show you over here. Yeah, you just sub in the H with 20. Okay? Can Okay, is that relevant? Sorry, it's not relevant. I just want to let you know. Hey, wait, no, sorry, it is relevant. Yeah, I need to solve for C. Forgot. Okay, so that's exactly what I did. When t equals 0, H equals 20. I just substitute. Finding the volume maybe not so relevant. Just knowing the H is good enough. Initially, H equal to 20 because the volume of water is the same as the volume of the container. So the height of the water is the same as the height of the container, which is 20. Okay, so therefore on the left side, H, we sub with 20. On the right side, minus 2t squared minus t plus c. Substitute t with 0 plus c. And I obtain this equation. From there, I can solve for c equals 20. Okay so far? Then just sub the c with 20 back in over here, and I get h equals to this function here. Okay, that's good. From there, we can solve the question already. Because previously what we have is something in terms of h. We want to substitute with what? Look back at what you wrote down, WTF, dv by dt, substitute t equal to 2. That expression, substitute t equal to 2. That expression, substitute t equal to 2. We want to sub t equal to 2. Here we can sub t equal to 2, clearly, because there's a t. Here we cannot, but we managed to find h in terms of what letter? T. Then we can just substitute back in. Then now we will be able to obtain an expression in terms of t, substitute t equal to 2, and then we are done. Does it make sense?
Yeah.
Okay, and that's all I did. The rest of the working, I just substituted. I did it a little bit differently. Maybe I write down whatever I just said first. So previously we already had this formula here. Another way. Then we can replace the h with the formula we found, which is minus 2t squared minus t plus 20. Right, so it becomes 3 times of this square plus 4 times of that. I'm running out of space. Let me just wait. Let me just shrink it down a bit. Plus 4 times of this. All divided by 10. multiplied by minus 4t minus 1. Then you just have to sub t equal to 2 and you're done. Okay?
Yeah.
That is one way. The other way is what I did was I just substitute t equal to 2 first. Then I get the h to be a 10. So inside here it's a 10. It's a 10 after I substitute t equal to 2. Then I just directly replace it with a 10. Okay. When t equal to 2, h equal to 10, then I substitute h with a 10. That will also work. Is that okay? Clear so far?
Yeah.
Very good. Okay, then that's all. That covers all of the questions you did for me. The rest, please go and try. 21, 22, 23, 24. Okay, actually I have time. Maybe I can go through some of the questions. Let's see. What would be good? Circle question, trigo question. Okay, maybe I should try this question. Have I went through this question already? Does it look familiar to you?
No.
No. Okay, we go through this because it involves trigo. Let's just go through this. Okay, let's take a look. Question 36. Please finish all the questions inside this, and I'll be giving you more. Try some more practice on e power x logarithms, and then application questions involving those functions. Okay, Ken, let's go. URA in Singapore is gazetting a piece of right-angled triangular shaped land ABC in Hougang Avenue 8. URA plans to build a public skate arena shown in the diagram. An area ABD is to be built with ramps. Okay, just ABD, let me just mark it. ABD is to be built with ramps. AC equals to 200 meters, BAD equals to angle theta, and theta is in between 0 to 90 degrees, strictly between, not 0, not 90. Part 1, show that the area A meter squares of the triangle ABC is given by that formula. How?
How?
What kind
Okay.
of angle do you see here?
Right angle triangle.
So how to find area of triangle ABC first? Half
Times height times base. Oh, half times half times half times sine 30 plus half times sine theta plus 30. Wait. Times
okay.
times the 200. Times
What is this? What is this? 200 times sine theta.
this is CB.
BC. I strongly recommend you to do this. Write it as sine and then so opposite over hypotenuse. Then you write down BC over 200 like this. Then after that, you multiply 200, you get BC. Okay? But yeah, also maybe even better, you should start off with BC. So what I mean is, you should start with half times base times height, because everybody knows that. So area equals half times, the base in this case is AB, the height in this case is BC. Or if you like BC first, then AB. Then what you are saying, yes, half times the 200 sine 30 plus theta. Continue.
AB.
You use sine already. What else? We need AB now. Just now you use sine because that's opposite
Yeah.
BC. So what's AB?
Use 200 cosine theta plus 30.
Yes. Okay, very good. Let's just write this down as cosine first, then use car adjacent over hypotenuse 200. Okay. Remember the goal first. Let's just copy down the objective. 5,000 times sine of 2 theta plus square root 3 cosine 2 theta.
Yeah.
Square root 3 sound familiar? Oh, square root 3. Where have I seen that number before? How is it related to 3 go? Tic-tac-toe. Remember? The 2 triangles, very good. Okay, go draw. Alternatively, use the calculator trick. Square and square root auto. You know. But okay. Give you some time to recall. Are you sure it's a 2? Are you sure? Oh, okay. Eh? Yeah, correct. Okay. Square root 2. Yes, very good. So if it's isosceles right angle triangle, what's the base angles there?
45, 45.
Also known in radians as pi over 4. Because we're about to do differentiation. So theta is in. Hold on. Is it theta degrees of radians? Oh, why did they give degrees? That's not good. Help me to change this. I'm gonna change this into radians. Sorry, just to make your life a bit easier. This is pi over 6. This is pi over 4. Because we're about to do differentiation. I don't want that irritating 180 over pi to creep up everywhere. Just treat it as radians. I am changing the question. Okay. Can carry on. Okay, so this is not 30, it's pi over 6. Okay, let me go and change all the 30s to pi over 6. Need circle? Oh, okay, I don't know.
Wait. I thought you would say something like you draw circle then you extend or something. No. Okay, I guess not. Okay, never mind.
Tangent to a circle, huh? Wait. Oh, you're trying to draw equilateral triangle, split it in half, right? So let me give you a hint. 2, 2, 2 first for the length. Yeah, split half. Correct. Yes.
Come
2 is like the radius of a circle, I guess. Not important, but square root of 2
square root 4 square root 3.
3. With that, can I just help you to draw it so it looks nice at the side?
Yeah, sure.
Pi over 4. I'm gonna use radians instead, okay? Don't care, you have to get used to it.
Oh shoot.
2, 1, 1. This is 60 degrees because equilateral triangle, which is pi over 3. This is pi over 30 degrees, so it's 60. Pi over 6. This is 90. Here's square root 3. You can chop off the right side. Just focus on one side of the triangle. 1, 2, square root 3, 60 degrees, 30 degrees, 90 there. Help me to erase your drawing. Yeah, we'll just use that diagram at the bottom. Okay, carry on. Sine theta plus 6 and cosine theta plus 6. Here I got 2 theta and 2 theta. So start expanding and then do some identities. Let's just work it out. Together lah. Half times 200. Let's okay. Half times 200 times 200. What does that give me? 100 times 200. So it's 100 times 200, which is how many zeros? 1, 2, 3, 4. 20,000. A bit off. A bit off. You see, you need what? 5,000. Here is 20,000. So must be okay. Wait, hold on. Pause a while. Pause a while. I might have written something. Let me read the question carefully. Find the area of the triangle ABC. So it's the whole thing. Okay, we got no choice. Yes. So we're a bit off. We're off by a factor of what? 4, right? Off by a factor of 4, yes.
Mm-hmm.
So that means we probably need to do a bit of what we need a 1/4 somewhere. But never mind, let's just continue first. So sine of this guy pi over sine theta plus pi over 6 times the cosine theta plus pi over 6. Inside the sine, inside the cosine, do you see a plus angle? Do you see an addition of angles going on? No, right? It's just 2 theta,
No.
2 theta.
Yeah,
So that means here we got addition. Open it up.
Yep.
Just to help you out. The
Sine
formula
theta
is
cosine sine theta cosine pi over 6 plus cosine theta sine pi over 6.
this is my lazy way of writing. Can you understand what it means?
Yeah.
Sine of A plus B equals to sine A times cosine B plus cosine A sine B. Okay, plus minus, plus minus. Sine is well behaved. Cosine is the rebel. If here is plus minus, the other side is cos A cos B minus sine A sine B minus plus. Okay, opposite way. So let's just do that. So 20,000 multiplied by, let's just draw a big square bracket, sine A cos B plus cos A sine B. I am running out of space. Let me move everything to the left a bit. And I'm gonna make the font size a bit smaller. And then this is 2 terms. That's sine of theta plus pi over 6. It's being multiplied by the cosine. So you need to draw a pair of brackets, then multiply. Okay, so let's do that. Cosine theta cosine pi over 6. Plus or minus? Tell me. Rebel. Plus or minus? Minus must be different. Different. And then sine A sine B. Very good. So now that you know what is you have drawn the nice little diagrams on the right side, can you tell me what is cosine pi over 6 and sine pi over 6? Start off, cosine pi over 6, what is it?
Cosine pi over 6 is adjacent pi over 3 divided by 2. Yeah.
Pi over 3, square root 3, you mean?
I mean square root 3 over 2.
Square root 3, yes, very good. Square root 3 over 2. Okay, how about sine pi over 6?
2 1/2. It's just half.
Wrong.
Wait.
Correct. You're correct. I'm wrong. I'm tired. Okay. Cosine pi over 6? It's the same thing.
Yeah, okay.
3 over 2, sine pi over 6, 1/2. Okay. Very good. So let's just write it neatly. So it's square root 3 over 2 times sine theta plus 1/2 times cosine theta. Bracket again. Square root 3 over 2 cosine theta minus 1/2 of sine theta bracket square bracket. 20,000. Remember, we're missing a factor of how much? Final answer need 5,000. Here is 20,000. Factor of
Yep. Factor of
20,000. We need 5,000. We currently have 20,000. So we need
Yes.
to
get rid of 4.
divide by 4. So we need to essentially multiply by a 1/4, right? Can you see how we can get a 1/4 from these guys?
Yeah.
How about this part? I suggest you factor out a half first. Then we end up with, okay, maybe I'll just, with the power of an iPad, I can copy and paste. Just move this a bit faster, so we end up with this plus this plus this and close the bracket like this. Is it okay with you so far? Factor
Yeah.
out the half? Okay, very good. So of course the other guy, you can also factor out a half. Let me just copy and paste this to save some time. And this just changes from sine and cosine to cosine and sine, and the plus becomes a minus. Clear?
Yeah.
Same, right? Agree? What's half times half?
Half times half is 1/4.
1/4. Very good. So that means that we can now finally have the correct factor. 20,000 times 1/4 times square bracket, whatever was red color on the left, multiplied by whatever's on the right in red. Okay, good. We have obtained our 5,000. Still not done. Still have more work to do. Here is in terms of theta, theta, theta. There is in terms of 2 theta, 2 theta, 2 theta. Sine 2 theta plus square root 3 cosine 2 theta. Okay. Oops, I think I covered out a bracket. Yeah. Okay, so that means that we need to still do a bit more identities involving double angle. But before that, let's just multiply it first. Multiply it out first. Okay. So first one, root 3 times root 3 becomes a 3. Sine times cosine. So 3 cos, 3 sine cos. Okay. Second term, root 3 sine times negative sine becomes negative root 3 sine square. Next one, cosine times root 3 cos becomes positive root 3 cos square. Positive cos times negative sine, negative cos sine. Or I like to put the sine first before my cosine. Okay, very nice. Anything to cancel?
Anything to cancel. Two sine theta cosine theta.
Very nice. So we can change this to from 3 to a 2, remove the last guy. Okay. Then always look back at the ultimate goal. Let's take a look what we need. Sine 2 theta plus root 3 cosine 2 theta. Oh no, I am stuck with my trigo proof. What do I do?
Stuck.
I'm trying to prove this is equal to this. Stuck, then what do you do?
Okay, special identity. What will you do?
I would work from the back and work towards the front. Right, you know, meet in the middle idea?
Wait, can you factor out the square root 3? I mean, yeah, the factor
I
of
also
square
can.
root. Then
Actually, we are quite close already. I
sine
think I
square
saw the better.
plus cosine square equal to 1.
Here you are making a mistake.
Cause it's negative.
There's a minus.
Negative. Okay.
So what would it be? What do you want to factor out? Positive square root 3 or negative square root 3?
Negative square root 3.
Negative square root 3, okay. Then this one, no choice, must be minus minus become a plus. So there must be a minus here.
Okay. 1
3
cosine.
at this stage.
And sub in
Perhaps it would have been smarter if you factor out a positive root 3, because over here is a positive.
Oh, okay. Yeah.
So let's do that instead. So in this case, we do a positive root 3 factor over here. Then I just have to swap the order. Cos square goes to the left, sine square goes to the right. No. At this stage, I just have to tell you, we have already reached the end. This is the answer already. Ding. Why? Because it's in the formula list. It's in the formula list. Sine 2 theta is 2 sine theta cos theta. Do you
Yeah. Okay. Yeah.
you want the proof?
No, then what about for this one? Oh yeah.
Cos
Okay. I
theta
see. Okay, never
minus
mind.
square. It is one of the three. Remember, got three of them. The other one is 2 cos. Let me double check first. Cos square become 1 minus sin square. Yeah. Then the other guy is 2 cos square minus 1. Okay. These three identities for cosine 2 theta, that single identity for sine 2 theta. Okay, then we are finally done with this part. Not even doing the differentiation yet, it's already quite difficult. Okay, but anyways, back to part 2 now. Part 2, find dA by d theta. That's when you need to use your sine and cosine tricks. Okay, so let's calculate dA by d theta. Okay, what would it be? Let's see. So 5,000 factor, I will just leave it alone. Then d by d theta of the rest. I'm just going to put dot. I hope you get what I mean. The expression in the bracket. I'm trying to save some time. Okay, then you differentiate with respect to theta. Just draw a big square bracket. Differentiate the first guy, sine. What do you get?
You get cosine 2 theta is
Cosine.
cosine 2
Then
theta
copy
times
the
2 times 2.
times 2. Well done. Very good. Because of
Yes.
chain rule. Next one.
Bring
I
out
see
the
plus. I copy.
3. Bring out the root 3. Can
Three.
factor out. Then differentiate the inside. So negative times negative sine 2 theta times 2. Plus chain
Very
rule.
good. Very good. Yes. Because of chain rule. Okay. But when you root 3 times, must put bracket, okay?
Yes.
Just put bracket. Don't let the times and the minus sign meet each other. Two signs cannot meet each other. Okay, so let's just simplify this. 5,000, leave alone. This guy is 2 cos 2 theta. I don't need the time symbol anymore. In fact, I don't even need the brackets anymore. Here I have a positive times a negative 1 times a 2. So that gives me a negative 2 root 3 sine 2 theta. Is that okay? Very good. I can factor out 2 as well. So I get 10,000 times cos 2 theta. I'll just put a bracket. Minus root 3 sine 2 theta. You put a bracket, you don't put, is fine. It's both are fine in this case. Very good. Then what's the next question? Part 3. Find the value of theta for which the area of the triangle ABC is maximum. So here they already told us it is maximum, so you don't need to do the table. First derivative test. Okay? When they tell you it is maximum, you don't need to determine the nature. Okay. They already tell you it's maximum, don't need to show anymore. The other way that they will phrase the question is find the stationary point and determine its nature. In that case, you need to do the extra step, the table or the second derivative test. Okay. Yeah, so how? What's the mnemonic I teach you? Star. Yes, very good. Do you need a tar?
No.
Don't need for this case. Differentiate, done already. Then
equate to 0 for SP. For SP set dA over d theta equals
you don't have
0.
to use the word set. I can use equate or anything that makes sense. Okay, equal to 0 exactly. So therefore, you get this expression over there. Oh, please drop the equal sign. Equal should only appear one time in one row in the best presentation. Okay, equals to 0. Now I purposely factor out the 10,000 so that I can divide by 10,000 and divide by 10,000. Extra missing 0. Cancel away 0 over 10,000 is just 0. So I can get rid of it. Yes. So this means I'm left with, oops, sorry. This guy equals to 0. Okay. Wow, you see, A cosine theta plus B sine theta equals to C. Then you're gonna use R formula, is it? Remember R formula?
Yeah.
Please don't. Please remember the special case. There's a sine, there's a cosine, there's a zero. What should you do?
Bring to the other side.
Bring to the other side. Don't use R formula yet. Overkill. So bring it over, you get root 3 sine 2 theta. What's a key identity you need to remember involving sine and cosine?
A key identity I need to remember.
A formula. So
formula.
you got S, you got C. What's the last letter?
Then
You got
wait,
S, you got C. Tangent.
Tangent.
Yeah, so tangent. You must think when you see sine and cosine, think of tangent. What's the formula for tangent involving sine and cosine? Just now I asked you.
equal to sine over cosine.
But in this case, the angle is 2 theta, so it's no longer just a single theta. It should be 2 theta like this. And then 2 theta, 2 theta. Okay? Okay, yeah. So let me just rearrange it so it looks a bit nicer. So root 3 sine theta, sine 2 theta equals to cosine 2 theta. Then from there, what can we do? This
Can
equal sign from
bring
zero means this implies that.
cosine. You can do cotangent theta equals
I don't have cotangent inverse on my calculator, so wouldn't it be nicer if you just
yes. Okay. Tangent 2 theta equals to 1 over 1 over square root 3.
very good, nice. 1 over square root 3 tangent. Let's take a look at this triangle again.
Yep.
Yes, tangent. Which one has 1 over square root 3?
It's the 2 theta equals to pi over 3.
So you're saying that tangent of pi over 3 opposite over adjacent.
Wait, I mean pi over 6. 2 theta equal to pi over 6.
So you're saying you can go straight from theta to theta? How do you usually solve a trigo equation? What's missing in between? In general, I know in this case, theta is in between 0 to 90 degrees, so it's only quadrant 1. But what's a general method?
Or 2 theta equals to pi
Is it, do you
over
start with
6?
2 theta? No. Find your, what's the other letter, the other Greek letter? 1 theta is the
Alpha.
fish. Alpha, your basic angle, remember?
Okay.
Must remember this, this is the general method. You don't go to engineering and you don't know how to solve trigo equation. Wow, this one very, very, very bad. You must know alpha, also known as basic angle or reference angle. Okay, that's a general method. Then also, I draw this x and y axis. What do I want to label? All science teachers
Are crazy. Q1, Q2, Q3. ASTC. Okay.
1, 2, 3, 4. Okay, actually, you don't remember the quadrant, it's fine. You remember ASTC more important at the positions. Okay, good. So in this case,
quadrant 1 or quadrant 3?
Very good, you remember. Okay, quadrant 1 or quadrant 3. So in this case, alpha, we found out it is just, in this case is pi over 6. So that means that 2 theta equals to the alpha, positive, so quadrant 1, quadrant 3, right? Let's say this is the quadrant 1 angle. The other case will be, or this is the quadrant 3 angle. So quadrant 1 angle is pi over 6. Quadrant 3 angle will be?
Pi plus pi over 6.
Very nice. Okay, of course, at this stage, you can just reject this already, because we know that theta is, remember, it's in between 90 degrees and 0 degrees.
Yep.
Over here, in order for the diagram to make sense, this angle must be less than 90. Like this angle must be less than 90. But I changed to pi over 4, 90 degrees. Let me double check. Sorry, apologies. It's not 4, it's 2. Sorry. 2, not 4. Pi over 4 is 45 degrees. Pi over 2 is 90. Pi is 180, so pi over 2 is 90. Yeah. Okay, Ken, so pi over 2 is 90 degrees. We're gonna write that instead. Pi over 2, this is just 0. Okay. Very good. So that means that, of course, 2 theta must be in between pi and 0. Correct or not? Just times 2. Yes?
Yeah.
If you have pi plus pi over 6, it's already more than pi. So straight away, you can reject the answer. Is that okay?
Yeah.
Okay, good. So they are left with 2 theta equal pi over 6. That's a proper way to do it. The most general method. And then because of the special case, then you simplify down to only one answer. You reject the extra solutions. Okay, moving on. So as a result, get pi over 6 divided by 2, which is pi over 12 to solve for theta. 2 theta becomes theta, just divide by 2, yeah? Good.
Yes.
That's the answer already. Done. That's how you solve a Desta kind of question, where the first step you set up an equation involving trigonometry. This is almost as difficult as it gets really for A max level. Okay. Yes. Let me see. What else should I go through? Okay. Your homework will be to go and finish up the rest of the questions in that worksheet. I will also be sending you more questions involving involving, what do you call it? Desta procedure, but you need to set up an equation involving sines and cosines. And I will also assign you some questions that have logarithms inside, so you can practice differentiation with logarithms. Okay?
Okay.
That will be all. Actually, I still have some extra time. You got any questions you want me to go through?
Not specifically.
Not specifically. Okay. Then I go through some practice questions on logarithm. Let's see. What is good? Is this a good idea? Maybe. Have we went through this already? 17.3. I feel like we have. We try some exponential questions since you haven't done it. Okay, let's try 9 and 10. Oh, wrong file. This one. Let's take a look at this question. Question 9, very basic. Question 9, part 1. Given that y equals to e to the power of negative 2x divided by 6, you want to find dy by dx. How?
Okay. Factor out the 1 over 6 and times d over dx e minus to the power of minus 2x. Okay, then below 1 over 6 times leave as the same times bring down the minus 2.
Not bring down, more like there's a negative 2x, you're differentiating negative 2x. Don't say bring down. Sorry?
Yeah.
Don't think of it as bring down. If not, you may confuse with differentiate x power n, where n can be any 1, 2, 3, 4, 5, 6, 7, 8. And n minus 1
minus
power.
1. Okay.
Don't confuse with this one. Don't say bring down. Very bad. Say
This one,
differentiate the inside.
Chain
This is
rule.
like an inside function. This is an outer function. Yes,
Chain
the
rule.
outer function e power something differentiate happens to be exactly the same. Then inner function you differentiate again by chain rule.
Okay.
You get -2. Okay, can simplify -2/6 become -1/3 e power -2x. Okay, that's part one. Let's move on to part two.
Find dy over dt if dx over dt is p. Okay. WTF dy over dt given dx over dt go to p when
X
x
equal to
equal to
1.
1. Yeah.
Ah,
dy over dt equals to dy over dx times dx over dt. Yeah.
good.
Then you have dy over dx from the part I, and then they give dx over dt equals to p. Yeah. Then you
Maybe just to remind you of your notation.
Yeah.
When you substitute
this.
in with p, right, it becomes a value. So you are substituting. You need to put vertical line x equal to 1. Vertical line x equal to 1. Vertical line x equal to 1. Be consistent. Okay, you don't just put in vertical line x equal to 1 time. You do it for all of them.
Oh,
You
okay.
either do it for all of them or you do it for none of them. One or the other. Okay. So yeah, it's best to just put in all. Okay, so as a result, we get this. Then what does vertical line x equal to 1 mean?
Sub in x equals to 1.
So okay, let me just bring the x equal to 1 a bit lower. It's supposed to be like you write whatever inside this box, you draw a vertical line, there's a bit of space over here, then you write down x equal to 1 at the bottom right corner. Yeah, that's the notation. Anyways, sub in, you get -1/3 e power -2 times 1 times p. Make it look nicer, -p e power -2/3. Okay, make it look even nicer. The e can go down, 3e squared. That's the exact answer. Don't use a calculator. Don't need to use a calculator. Yeah. Okay. Yeah, that's it for the question 9. Moving on, question 10. Let's take a look. Electricity. Okay, the charge Q coulombs through a discharging capacitor at time t seconds is given by the equation Q equals to -E times C times e to the power of -1/r times C. I guess it's the same C, not sure. E, R, and C are constants. Capital E, capital C, and capital R, they are constants. The C appears 2 times. E is the electromotive force in volts. Wow, what is that? Never studied before. I didn't study physics. Okay. R is the resistance in ohms. C is the capacitance in farads. There's such a unit. I am not sure. But it doesn't matter because this is a method. The current is defined as the change in charge per change in time. Okay. So what does it mean? Change in charge per change in time. When you see the word per, you know there's a rate going on already. So what over what? And when you think of rate of change, you will think of differentiation. So d what over d what? Change in charge or per change in time. What's charge again? What's the letter representing charge?
Yeah, which one?
Read the sentence, the first sentence.
Q, dq
Q.
over.
So here is charge. Take note that this little e here is the number 2.71828. E is 2.718281828 ... Okay, it's just a constant over here. Right? Not even, and then there's a variable over here. Okay, but anyways, dq over dy. Time. What letter? T, exactly. So that's all they're asking. This is also, that's all they're telling you. This is defined to be is actually written like this. put a colon like this and put an equal sign. You read this as defined to be equal to. The current is defined as current. Okay, the current. Current, I think the letter is A. I'm not sure. Don't quote me on that. Determine in terms of E, R, and C, the instantaneous rate of current flow at time 3 seconds, leaving your answer in natural exponential form. This is also known as the natural exponential. Euler's number or exponential, natural exponential. Oh,
Okay.
yes. Am I still connected?
Yeah.
I think my screen froze. Oh, my Wi-Fi is down. Oh no. My laptop has some issues. Mic test, can you hear me?
Yeah.
Okay, give me a second. I need to join using my other device. Oh no. This. Wow. Like this. Can you hear?
Yeah.
Okay. There might be some echo. Let me see if I can share my screen. How do I do that? Share screen. Mic test, can you hear me?
Yes.
Okay. Let me. Mic test, can you still hear me?
Yeah.
Yes, okay, good. Let's begin. I'm using my iPad now. Yes, so this is the Euler's number, all right? The Euler's number, or you can call it the natural exponential. Natural exponential. Okay, good. So what they want you to find is the instantaneous rate of current flow at time 3 seconds. So yeah, rate of current flow. So if I am not mistaken, what they want is simply dq by dt. This is not just current, this is rate of current flow. All they want you to find is dq by dt given that t equals to 3. Yeah, that's it. Okay. Okay, then in this case, how do we do this question? You need to figure out which expression are constants, which expressions are not constants. So in this case, Let's see what information they gave us. Let me see. How can I do this question? They didn't give me a function of time. This is a constant. Is it missing a T? Okay, I'm gonna change the equation.
Okay.
Oh, there's a T. Sorry, I didn't see it clearly. The photo wasn't clear enough. I thought this was a 1. This is actually a T.
Oh, lol.
Right. That makes more sense now. Oh, okay. That makes a lot of sense now. So everything is just a constant, a whole bunch of constants, then there's a T there. So how to differentiate this? Let me just show you. What you need to do first is to figure out which are the constants, which is honestly just a whole bunch of essentially nonsense. Constant multiplied by e raised to the power of another constant here, r times what -1 over r times c multiplied by a t. Essentially, if you have like let's say for example y equals 5e to the power of -1 over 7x. How do you do dy by dx? First, you leave the factor alone, 5. Then you multiply by that same quantity, e power whatever, multiplied by, here you need to use chain rule. Then you end up with -1 over 7. Can you see what I'm writing? Can now? Good. If you know how to do this, you also know how to do that other question, because all you need to do is to treat the -e times c as 5, treat the -1 over r times c as -1 over 7, and proceed to differentiate. So let me just demonstrate. So dq by dt, leave the constant -e times c alone, multiplied by e power anything, very easy. Copy and paste. Let me shift things a bit so I have more space. Copy and paste. And then you multiply by the derivative of this guy, right? Because of chain rule. Because of chain rule. Multiply by derivative of this guy. What is it? Constant times t.
Okay, 1. Wait. What? Minus 1 over r times c. Then the t just is 1. So
right. This is just a bunch of numbers. You pretend that r is like a 8 and c is like a 9. 8 times 9 is 72. So it's -1 over 72. It's a variable like r times c. Okay, I don't know what's the actual value of r and c, but it's just a constant, just a number, right? So it's just a negative number over number. So whole thing is just a number. Number times t, how do you differentiate that? It's just a number itself, okay? And then you're done. But we actually need dq by dt given t equals to 3, right? So last step, substitute t equal to 3. Done. And leave everything in terms of ER and C. So physics application of math. Not that difficult, huh? Not that difficult. So here times 3. Done. Sorry, this is not the final answer. Sub in t with 3. Okay. Good. Okay. Can. I think that's all the time I have for today. That will be it. I'll assign you the question later. Can. Thank you.
okay.
Can.
Okay,
Bye-bye.
thank you.
And thank you.
Bye.
Bye-bye.